Prashant. Now we talk about hardware production mechanism in modern operating system. We are someone topics now we see introduction of hardware production, types of hardware production mechanism, memory management techniques, CPU privilege levels, input output production, case study and practical implementation, future action in hardware production. First, introduction of hardware production. Importance of hardware production: preventing unauthorized access, preventing and hardware safeguard sensitive data and ensure only authorized personnel can interact with critical system component, ensuring system stability. Ensuring system stability involves production hardware from tampering or malfunction, thereby maintaining consistent performance and preventing crashes. Historic background: early computing system, evolution of hardware production mechanism. Early computer system had minimal hardware protection, rely on physical security and rudimentary access control to safeguard hardware resources. The evolution of hardware production mechanism has led to sophisticated methods such as encryption, secure port, and a hardware firewall to enhance security. Second one, types of hardware production mechanism. There are two types: address space isolation, paging, and segmentation. Address space isolation ensures that each process has its own separating memory space, preventing unauthorized access to other process memory. Paging and segmentation techniques are used to manage memory more efficient, allowing protection against unauthorized memory access by dividing memory into blocks. Privilege level interpret handling. Privilege level in CPU determine the level of access of program or a user as enhancing security, restricting sensitive operation to higher privilege levels. Interrupt handling mechanism ensure the CPU handles hardware and software interrupt correctly, maintain system stability and security. Device control direct memory access, buffer and coaching. Device control mechanism involve managing access to hardware device, ensure that only authorized process can communicate with and control device. DMA allow the device to transfer data and, from memory without CPU intervention, requiring protection to prevent the unauthorized memory access. Buffering and caching techniques are used to improve I/O performance while ensuring data intelligence and protection from unauthorized access or tampering. Third one is memory management and techniques. Benefits of virtual memory addressing translation. Logical addressing. Logical addressing is segmentation including divided program into segment, each a logical address that allow for easier management and production of memory. Segment description. Segment description provides metadata about each memory segment including base address limit and access privilege, helping in addressing and memory production. Combined segment and tagging. Combined segmentation and tagging offer benefits of both technique allow for flexible, efficient memory management and reducing fragmentation. Fourth one is CPU privilege levels. Ring O kernel mode. In Ring O, the CPU has full access to all hardware and can execute any CPU instruction. It's mainly used by operating system kernel. Ring 3 user mode. Ring 3 restricts access to hardware and critical system functions, reducing the risk of accidental or malicious interface. It is used for running application and user process. Transition mechanism, system call and interrupt and exception. System call provide a controlled interface for user application to request service from the kernel, enabling safe transition between user and kernel mode. Interrupt and exception are hardware triggering event that promote the CPU to temporarily switch from user to kernel mode to handle urgent tasks or errors. Hardware support, supervisor mode and hardware protection bytes. Supervisor mode is a CPU state that enable execute of privileged instruction necessary for the operating system function and management of hardware resources. Hardware protection bytes are setting that enforce access restriction on memory and a resource, preventing user mode process from performing unauthorized action. Fifth one, I/O protection, input-output protection. Device drivers. Role of device drivers. Device drivers act as intermediate between the operating system and the hardware facilitating communicate and functionality management. Protection in kernel mode. Kernel mode protection ensures that device drives operating securely, preventing unauthorized access and maintaining system stability. DMA, direct memory access. It has two types. DMA control. DMA control allows to access main memory directly by passing the CPU to enhance efficiency in data transfer process. Security implication. The security implication of DMA include potential such as unauthorized memory access, necessitating robust security measuring. Buffering method. Description of blocking and non-blocking I/O. Blocking I/O waits for operation to complete before proceeding, while non-blocking input-output allows other processing during data transfer waits. Circular buffers. Circular buffers managing ongoing data stream effectively by reusing memory space, ensuring continuous operation without overflow or underflow. Sixth topic is case studies and practical implementation. Now we about real world implementation. Linux kernel security. Memory protection in Linux. Memory protection in Linux involves various mechanisms such as non-executable memory, address space layout, randomization, and control flow intelligence is called also known as CFI to prevent unauthorized access and modification. Next one is CPU protection in Linux. CPU protection in Linux includes features like context switching, privileging levels, and process isolation to ensure that user processes do not interface with critical kernel operation. Windows operation system. Windows memory management. Windows memory management uses virtual address space tagging and various systems utilize memory resourcing among multiple running applications. Next one is Windows privilege levels. Windows privilege levels employ user account control, that is known as UAC, access token and a layered security model to ensure that system critical operations are only performed by unauthorized process and users. macOS security features. Kernel extension. Kernel access in macOS, also known as exit, allow developers to load custom code at the kernel level, managing hardware interaction while ensuring to security protocol. System Intelligent Protection (SIP). SIP known as System Intelligent Protection. In macOS, safeguards system process and files by preventing unauthorized modification, enhancing the platform's resistance against malware and accidental damage. Seventh one, future direction in hardware protection. Hardware-based security enhancement. Role of artificial intelligence. Detailed description about this title examine new hardware security solutions such as SecureBot and trusted platform modules designed to provide robust tamper-proof security mechanism. Role of artificial intelligence. AI is the most dominant now. So in future also AI is booming. Detailed description about this title discuss the integrate of AI in hardware security for real-time threading detection and response, leveraging machine learning to anticipate and mitigate security features. Potential challenge: balancing security and performance, adoption of new standards. Detailed description about this title shows how adding security features can impact the performance and explore techniques to achieve an optimal balance between security measuring and operating efficiency. A detailed description about this title highlights the complexity involved in implementing new hardware security standards and protocol, including industry concerns, regulator complaints, and interoperability issues. Thank you.